Hello students, I am Kundan Kumar, Senior Lecturer, Narayana IIT Academy. Let's today start discussion of JEE main paper, and today we are starting discussion of 29th January morning shift. So let's start discussion of physics paper, how is the paper, and we will discuss each and every problem in detail, and if some complication is there, that also I will explain, as well as whatever subject practice required and whatever relevant concept required, that also we will discuss. So let's start. Okay, fine. So this is our first problem, as we can see, and it is a assertion reason problem, as we can see. So you can see in assertion we have electromagnetic waves carry energy but not momentum. As you know, waves always carry energy as well as momentum. So 100% this assertion is false, because electromagnetic waves carry momentum also. So assertion is false. So I can say this one is false 100%. Okay. Second statement is mass of photon is 0. Actually we know that for photon its rest mass is 0. So although here mass is written, but we will assume that here mass of photon is 0 means actually examiner is talking about rest mass. So we can say that second statement is correct. So the correct answer is that assertion is false and reason is true. So we will go with option 1. So option 1 is correct answer. Assertion is false and reason is true. Okay. Let's move to next one. So here we can see that here we have a graph of u versus v. So let's read the problem formally. So let u and v be the distances of the object and the image from a lens of focal length f. So first of all it is lens. So we should highlight it is lens. The correct graphical representation of u versus v for convex lens. Obviously they have said u greater than f means they are talking about in case of real images. Okay. So we know that lens formula we have 1 by v minus 1 by u equal to 1 by f. Okay. Now here we can see that here for real scenario, let us say u equal to something minus x, u equal to minus x, and v will be, let us say something plus y, because we are talking about what? We are talking about a real image. So real image is on the other side of the lens, so v will be positive, and focal length for convex lens will be plus f. Let us put these values with us. So what we are getting? 1 by, I think v will be plus y, minus 1 by u is beta minus x, and is equal to 1 by plus f, correct? So from here we can see that this is the relation. Finally it is 1 by y plus 1 by x equal to 1 by f. This y is actually your v, rather you can say it is modulus of v, and x is what? You can say u or modulus of u. So how this relation looks like? This relation looks like, as we can see that from basic idea. What I can see? As x tends to infinity, if x tends to infinity, you can see that 1 by x tends to 0, so y tends to f, okay. This is one thing. Second, as you can see, similarly you can see as y tends to infinity, x means you can say x is modulus of u or simply u, here you can see in the graph. Similarly, if y tends to infinity, check, if y tends to infinity, so it implies x tends to f, Now from here what we can say? So now our graph should be, the correct graph should be, I can draw here. So let us say beta this is y and this is x. Again x is actually what? U, and y is actually here v. Second thing, that this graph is obviously non-linear. X versus y graph is non-linear because it is 1 by y, 1 by x. It is not a straight line. Y versus x graph is not a straight line. Now what I can say, what we got? Some points. First of all, we got these 2 points. Second thing, we can say that graph tends to infinity. So when x tending to infinity, then you have, when x tends to infinity, at that time you have which point? You have y tends to f. So y is equal to f when x is infinity. So somewhere here point, okay, very far. And similarly, when y tends to infinity, again it is somewhere. So, this is f comma f, let us say this is f and let us say this is f. So, here you have when y tends to infinity, again somewhere here point. So, now this graph is something non-linear and it should be like this. This is your graph, just focus. This is the graph. Now, this is the corresponding graph. Now, this graph you can see out of 4 options in which you can see this graph. So, you can easily understand second is correct answer. So, correct answer is second. Very simple. It is a theoretical question and every time we discuss this in class. So, very simple question. Okay. Let us come to next one. Next one is again very simple question. The work done in an adiabatic change in an ideal gas depends upon what they are saying. So, we can say that according to first law, we know very simple that Q equal to delta U plus W. Okay. This is by first law. Now, we know that Q is 0 for adiabatic process. So, I can simply say W equal to minus delta U for adiabatic process, but delta U is simply F by 2 NR delta T, okay, or you can say minus N CV delta T, both are same thing. You can see from both formula both are same, it means work done only depends on what? Change in temperature. So, I can mark which option is correct? Correct answer is 3. Fine. Okay. Let us move to next problem. As you can see next problem, what it is telling? It is a question from photoelectric effect, and what it says, emission of electron in photoelectric effect can be suppressed by applying a sufficient negative electron potential to the photoemissive substance. First of all, here this negative electron potential is, what is this language? So, again this is ambiguity. This electron potential should not be there, rather it should be electric potential first of all. So, this word is definitely wrong, this line is definitely wrong. So, I can 100% say that in assertion this line is incorrect, assertion line is 100% incorrect, because this wordings is definitely wrong. But let us say it is electric potential. So, 100% right now I can say assertion is wrong, but let us say it was electric potential, then this statement what I can say. So, we know that in photoelectric effect, suppose this is emitter and this is absorber, emitter is connected like this and this is our diagram, basic diagram I am making. So, this is emitter and emitter is negative terminal and here light is incident, here light is incident, and so electrons get emitted and they move towards this positive anode. This is the basic idea. So, you can see that emitter is actually connected with negative terminal of the battery, not positive terminal of the battery. To have photoelectric emission, emitter substance is connected with negative terminal of the battery. Now, if I have to stop this emission of electron, rather photocurrent ceases to 0, for that what I want? I want that electron should be reabsorbed, for that this emitter terminal must be positive. So, for stopping potential case, this diagram changes to something like this. In that case, the diagram is like this. This is the exact diagram and this is your stopping potential. At this, at a particular sufficient potential, that is what I can say, when this electron is actually absorbed by, even if it is emitted, it is reabsorbed. JEE Advanced has also asked this. So, at stopping potential, although electron is emitted, but it is reabsorbed by emitter itself, this emitter itself, and that is why photocurrent ceases to 0, that is what we are calling. And at this time what is happening? At stopping potential, electron having maximum kinetic energy is also unable to reach the collector. Collector means anode we are talking. So, since if I am assuming this potential as positive thing, then its polarity is just opposite. So, generally in the language, in literature, in books, we have found this as negative potential. But you can see, even if it is negative potential, the polarity of this battery emitter is always connected with what? Positive terminal for stopping potential case. Okay. So, this is one thing. So, 100% I will say assertion is wrong, assertion is wrong. Okay. Let us come to reason. A negative electric potential which stops the emission of photoelectrons surface a photoemissive substance varies linearly with frequency of incident radiation. That is what we are calling. So, let us see this. Right now only I said that at a stopping potential, electron having maximum kinetic energy is also unable to reach the collector. So, I can say, let us say this potential is V naught. So, electron will have, which is coming out, let us say it has kinetic energy K E and maximum kinetic energy. So, maximum kinetic energy. If it is also not able to reach, it means I can say work done by electric field, which is the negative work done, and it consumes what? It consumes actually whatever the kinetic energy electron has. So, I can say minus E V naught, which is the work done, equal to final 0 and initial kinetic energy K E max. Okay, very simple thing. So, from here what we are getting? We are getting E V naught equal to, and according to Einstein photoelectric equation, this E V naught is equal to this K E max. K E max is how much? K E max we know this is h nu minus work function, that is what we know. So, this is a very simple relation. Now, this simple relation what we can see? So, we can see that a stopping potential is obviously we can say it varies linearly with frequency, correct? It varies linearly with frequency, that is what we can say. So, second reason is 100% correct. So, I can say assertion is false, but reason is true. This is our explanation. Okay, fine. Let us moving to next one. Okay, next question, again a very simple question. What they are saying? Consider a long straight wire of a circular cross section, radius A. So, wire has radius A carrying a steady current I. The current is uniformly distributed across the cross section. So, you have seen a pipe which is a solid conductor, rather we should say in solid conductor. This is again in our basic, we can say, topic in magnetics, and we know that graph of this solid wire carrying current and it produces a magnetic field B. So, graph is something like this. We know this is our graph and this is at r equal to r, and after that this graph is inversely proportional. So, here B is directly proportional to r and here B is beta inversely proportional to r. This is a basic graph. I know that. So, for B inside, what is the basic formula? What is B inside formula? So, B inside formula we know it is, you can derive it, but right now I am writing mu naught I r upon 2 pi a square. This is the general formula. And what is B outside? What is B outside? So, B outside is very simple, mu naught I upon 2 pi r, where r is what? R is distance from axis of the wire. So, let us say this is wire and let us say this is axis. So, for inside this will be the distance, for outside this will be the distance. This is a very simple point. Now, what they are saying? So, let us come to the question. They are saying consider a long straight wire of circular cross section carrying a steady current I. The current is uniformly distributed across this cross section. Find the distances from the center of the wire cross section at which magnetic field inside the wire, outside the wire. So, both cases they are asking is half of the maximum. Maximum field is where? Maximum field is, you can see this maximum field is exactly at surface. What is B maximum? So, B maximum is beta mu naught I upon 2 pi a. This is the basic idea. Now, what they are saying? They are saying that B inside, you have to find a distance r. B inside is B max by 2, B max by 2. So, just put the formula of B inside. B inside formula is this. So, you can say mu naught I r upon 2 pi a square is equal to beta mu naught I upon 4 pi a. Very simple case. So, you can say something gets cancelled. So, mu naught I also gets cancelled. Okay, one a gets cancelled. Okay, and from here we get r equal to a by 2. So, this is inside point. You can see we got also answer for inside point because r is less than a. One more point we will get. For outside. So, let us use outside. So, B outside is again equal to, they are saying B maximum by 2. Let us come to this. What is B outside? Formula is mu naught I upon 2 pi r, and this must be equal to B maximum by 2, B maximum by 2. Right now we can say mu naught I upon 4 pi a, because B maximum we have written this, so it is half. From here we are getting R equal to how much? R equal to 4a. R equal to 4a we are getting, no sorry, R equal to 2a. Calculation 2 pi gets cancelled. So, R equal to 2a. So, we can say we got inside point R equal to a by 2, outside point R equal to 2a. Let us come to option, any option is there. So, we can see second option is 100% R equal to a by 2 for inside point and 2a for outside point. That is what we can see. It is a very simple thing which you can easily understand. Okay? Let us move to next question. Okay, next question, again a very simple problem, very simple. What they are saying? A coil of area A and n turns is rotating with angular velocity omega in a uniform magnetic field B about an axis perpendicular to B, obviously, magnetic flux phi and induced EMF E across it at an instant when B is parallel to the plane of the coil. Okay. So, let us say this is coil beta, okay, this is coil having area A and number of turns n, fine. Okay. It is rotating with angular velocity omega in a uniform magnetic field about an axis perpendicular to B. So, let us say in this whole region you have cross magnetic field for time being, but a cross magnetic field, okay, and let us say this is axis. So, I think it is exactly to your simple case. What they are saying is rotating with angular velocity omega uniform magnetic field about an axis perpendicular to B. So, this you can see, this is magnetic field is inside and this is your axis. So, axis is definitely perpendicular, line you can see this axis line is perpendicular to magnetic field. So, it is rotating about this with some omega, Now, if I have to write flux at any moment, so what I can say flux? So, let us say initial area vector is inward. Can I take area vector can be outward or inward? So, let us take initial vector inward. So, magnetic field is also inward, area vector is also inward. So, t equal to 0, what is angle? Angle is 0. Now, if it is rotating with omega, so after some time it will rotate by an angle how much? Theta equal to omega t, So, at that time flux will be how much? N B dot A, very simple, that is N B A cos of theta, and theta is how much? Theta is omega t, very simple. This is beta flux. Okay. Now, if I want to calculate EMF induced, which is nothing but minus d phi by dt, which is very simple. What I can say? So, it will be simply N B A and cos omega t will have minus omega, okay, minus omega, basic thing, and sin omega t, differentiation, okay, and one more minus is there. So, we will put, so EMF induced will have very basic formula coming N B A omega sin omega t, okay, fine. So, we got this is flux and this is induced EMF. Now, at what time they are asking? See, at an instant when B is parallel to the plane of the coil, right now at t equal, suppose the diagram which I have shown, B is in the plane right now, just you can see, is B in the plane? No, B is inside, whereas plane of the loop is, so right now you can see theta is 0 degree. Are they asking at theta equal to 0 degree? No. So, if it rotates by an angle pi by 2, at that time what will happen? When theta will be equal to pi by 2, then at that time what will happen? You can see B vector will be inward and plane of this loop will be also in vertical direction to the whatever paper, that is what we are saying, and they are asking at theta equal to pi by 2 actually. So, now we will put the value, let us put theta equal to pi by 2. So, how much we are getting flux? Put this. So, I think flux will be 0, flux will be how much? 0, and what will be EMF induced? So, EMF induced for theta pi by 2. So, it is equal to N B A omega. Very simple question. Again underline this. When B is parallel to the plane of the coil, right now B is perpendicular to the plane of the coil in this diagram, just check. So, when it rotates by pi by 2, then you will get this diagram, and so correct answer is phi is 0 and E is NAB omega. Option first is correct answer, correct. Let us move to next one. Okay. An electric dipole of mass m, charge q and length L is placed in a uniform electric field E equal to E naught I cap. Okay, they have given some. When the dipole is rotated slightly from its equilibrium position and released, the time period of its oscillation. Very simple question. Again, here something we have to understand. First of all, they are saying electric dipole of mass m. Now, dipole has two charges. So, this is mass of which charge? But it is very clear from next words, charge q. You know, dipole has net charge how much? 0. But if examiner is telling that dipole has charge q, it means it is giving charge of only one particle. So, from that we will understand that this mass m is also mass of only one particle. It means our system of dipole is something like this. This is minus q charge, this is plus q charge, and plus q has also mass m and this minus q also has mass m. That is what we will understand, and obviously this length is L. Obviously this length is L, that is what we can understand. Now, they are saying that it is placed in uniform electric field. So, when it is placed in uniform electric field, you know time period equal to 2 pi root over I upon Pe. How we get this? This can be easily derived, which you know torque equal to minus Pe sin theta, very basic question. Okay, and torque equal to I alpha equal to minus Pe, sin theta will be theta for small, what we can say, angle, and from here alpha equal to minus Pe by I theta, and Pe by I theta you can see this thing is SHM equation and this is your omega square. Okay. So, time period is 2 pi by omega, time period is 2 pi by omega, and that is what I have written here. Directly you remember the formula, there is no issue. Now, we will put the value. So, it is 2 pi. What is moment of inertia? First of all, moment of inertia about which point? Obviously, dipole is rotating about its centroidal axis. So, I about center of mass. So, what is I about center of mass? This one mass will have distance L by 2. So, m L by 2 whole square. Okay. But this is moment of inertia of 1, you have another mass also. Okay. So, you will have mass is m only, not minus m, 2 upon P, P will be how much? So, Q into L into what is E? E value is given E naught. Now, just a basic thing, so it will be 2 pi root over I think m L upon 2 Q E naught. I think we will get this m L upon 2 Q E naught. Is there any option? Is there any option? So, we can see 32 question number and answer is option 3. Option 3 is correct answer. Fine. Let us move to next one. Okay. Next is a very simple question coming from units and dimension. What they are saying? Expression given below shows the variation of velocity v with time and v equal to at square plus bt upon c plus t. So, they are asking the dimensions. Simple principle of homogeneity we will apply. What principle of homogeneity says? The terms which are added or subtracted, they must have same dimension. So, I can say at square and v, they are both side. So, dimensionally they should be equal. So, I can say v is dimensionally equal to at square. So, a is beta dimensionally v by t square. Is it okay? Dimensionally a is v by t square. V is L t minus 1 upon T2. So, beta it is coming L T minus 3, very simple. Now, what we can say about C? So, dimensionally C and T should be, because C is added to T. So, dimensionally C is equal to T. So, its dimension is simply T. Now, what I can say dimensionally? Dimensionally I will say that BT upon C plus T, this is also added and is equal to V. So, dimensionally V is equal to BT upon C plus T, but C plus T is also dimensionally what? This is dimensionally T only. So, I can say dimensionally this is BT upon T. So, T gets cancelled. So, dimensionally B is actually V. and V is what beta? L t minus 1, correct? Just very simple. Now what they are asking? They are asking dimension of A, B and C. So we have calculated. What is dimension of A? L t minus 3. What is dimension of B beta? So dimension of B is simply t, and what is dimension of B? Sorry, dimension of B is L t minus 1. Let us write the dimension of B. Dimension of B is L t minus 1, and dimension of C. Dimension of C is how much? Simply t. Okay. So what we are getting it up? What we are getting? Just check. It is very simple. So obviously it is coming L square, t minus 1, t gets cancelled, and this is t minus 3. What we can write this? We can write this as m0 L2 t minus 3. Very simple, nothing is there. So m0 L2 t minus 3. So which option? Which option? And option number 3. Option number 3 is correct answer. Fine. Let us move to next one. Okay, again a very fundamental and very basic question coming from EMI topic. What they are saying? Consider I1 and I2 are the current flowing simultaneously in two nearby coils 1 and 2. Okay. If L1 is the self inductance of coil 1 and M12 is the mutual inductance of coil 1 with respect to coil 2, then the value of induced EMF in coil 1. So you know that suppose you have this is one coil and beta this is another coil. Let us say this is coil 1, let us say this is coil 2. Now if in this there is a current I1 and in this beta there is a current I2, you know that because of I1 there is flux linked with it. So what is flux linked with first? So you know it flux due to this own current is given as something L into I1, fine, this is one flux. But because of this current also there will be field lines, okay, there will be field lines, can I say, and these field lines are passing through this also. So you know that because of current in second coil there will be flux linked in first coil also, and that how we relate? We relate with mutual inductance. So we know that here total flux will be L I1 plus M12 I2. This is very simple. Okay. Now what they are asking? EMF. So EMF is minus d phi 1 by dt because E1 they are asking. So E1 equal to minus d phi 1 upon dt. So just put the value. So it is minus L d I1 by dt minus M12 d I2 by dt. Very simple. So what we will get from here? Which option? Which option? You can see EMF minus L1 d I1 by dt minus M12 d I2 by dt, which you can see option number 3. Option number 3 is correct answer. Okay. Let us move to next one. Okay. Next question. So next question is coming from, you can see, I think this is question coming from optics, geometrical optics, ray optics. What they are saying? Just we will read the problem. At the interface between two materials having refractive index n1 and n2, the critical angle for reflection of an EM wave is theta 1c. Okay, fine. The n2 material is replaced by another material having refractive index n3 such that the critical angle at the interface between n1 and n3 is theta 2c. Okay, fine. And if n3 greater than n2 greater than n1, so this is to highlight n3 greater than n2 greater than n1 and some n2 by n3 equal to 2 by 5, and they have given sin theta 2c minus sin theta 1c equal to 1 by 2. So first of all, what is sin theta 1c? So you know sin theta equal to sin theta c equal to 1 by mu, 1 by mu. What was mu here? So mu of denser with respect to rarer. This was a very basic idea. So right now here, suppose medium is n1 and n2. So you can see n2 is greater than n1. So it will be 1 by n2 upon n1. So which will be simply n1 upon n2. By same logic, sin theta 2c will be what? Sin theta 2c is for which medium? Just check. So it is for n1 and n3. Again n3 is greater. So I can directly write it is n1 upon n3. Very simple. Correct? Now they have given something that sin theta 2c minus sin theta 1c equal to 1 by 2. Fine, we will put the values. So, sin theta 2c is beta how much? n1 upon n3 minus sin theta 1c is what? Sin theta 1c n1 upon n2, and this is equal to 1 by 2. Okay, fine, correct. Now, they have given something n2 by n3 equal to 2 by 5. So, from here can I say n2 equal to 2 by 5 n3, just replace this. So, n1 we can take common, okay, n1. So, n1 by n1 you can take common, this is 1 by n3 minus beta n2 is 2 by 5 n3. So, n2 is 2 by 5 n3. So, it will be 5 by 2 n3, and beta this is equal to 1 by 2. So, you can see this is very simple, n1 upon n3 and 1 minus 5 by 2, 1 minus 5 by 2. So, 1 minus 5 by 2 is how much? Minus 3 by 2, am I correct? This is coming how much? Because it is 2 by 5 now. So, you can see simply 2 minus 5. So, this is equal to 1 by 2. Okay, 2 gets cancelled. So, from here we are getting n1 upon n3 is equal to minus 1 by 3. Okay. So, this is minus 1 by 3, fine. So, what is sin theta 1c? Sin theta 1c is n1 upon n2, n1 upon n2. So, just we will put here, let us put here. So, what I can say? I can say sin theta 1c, which is n1 upon n2, which is nothing but n1 upon, and n2 is again 2 by 5 n3. So, 2 by 5 n3, and n3 we have got how much? n3 equal to, from here you can see n3 equal to minus 3 n1, n3 equal to minus 3 n1. So, this is minus 5 by 6. So, theta 1c is sin inverse minus 5 by 6, minus 5 by 6, something like this. There is no such option, there is no such option which we can see. Okay. So, here we can easily say that there is no such option and it is negative thing. So, 100% this question will go for bonus. Out of 4 there are no options. So, this question is 100% bonus. Okay. Let us move to next one. Next question is, I think, 2 projectiles. So, I think it is from kinematics. Let us come to question what formal language is. So, 2 projectiles are fired with same initial speed from the same point on ground at an angle of 45 minus alpha, 45 degree minus alpha and 45 degree plus alpha, okay, with the horizontal dash. So, angles are with horizontal, basic whatever formula we derive in the same way. So, horizontal, there is nothing like vertical from, okay. The ratio of their maximum height. So, what is the formula for maximum height? So, maximum height formula you know uy square upon 2g, and what is u? So, it is u square sin square theta upon 2g. This is a very simple formula. So, they are asking ratio of maximum height. So, h1 upon h2, we will put the value. So, u square upon 2g sin square 45 minus alpha upon u square by 2g, I think speed is same, sin square 45 plus alpha. Such a simple problem. I think this gets cancelled. Now, little bit hard work we will do. What is sin 45 minus alpha? So, sin 45 1 by root 2 sin A cos B, okay, minus cos A sin B, cos A means cos 45 sin B and whole square upon how much it is? Again it is the same 1 by root 2 cos alpha, I think here plus sign is there, sorry, cos alpha plus 1 by root 2 sin alpha whole square. Fine, very simple. 1 by root 2 is everywhere cancelled. Now, this is how much? So, this is cos square, if you open this square, cos alpha minus sin alpha, cos square alpha plus sin square alpha minus 2 sin alpha cos alpha, correct, upon this is what denominator cos square alpha plus sin square alpha plus 2 sin alpha cos alpha. What is this? This is 1. So, 1 minus, now 2 sin alpha cos alpha is what? Sin 2 alpha, and 1 plus sin 2 alpha, very simple, sin 2 alpha. Is there any such option? So, we can see option number 4, exactly option number 4 is we are getting, okay. Very simple problem. Let us come to next question, okay. So, next question I think choke coil, okay. So, it is from AC, again a very basic question. What is this? Choke coil is a simple coil having a large inductance but a small resistance. I think this line is correct, okay. Choke coils are used with fluorescent mercury tube fittings. If household electric power is directly connected to a mercury tube, the bulb will be damaged. So, they are saying that if this mercury tube is connected without choke coil, then mercury tube will be damaged. I think this line is correct. Why it is correct? Because you can see mercury, let us say tube is a resistor and this is a choke coil which is an inductor, and if it is connected to a AC source, V equal to V naught sin omega t, very basic question. This is R, this is L. So, you know very well that current will be flowing. When I say current means let us take RMS current. So, current you can say either RMS current, maximum current, all will have directly proportionality. So, let us take RMS current. So, I is V RMS upon Z. Z will be how much? Root over R square plus omega L whole square. This is the reactance, okay. Because of this, if this is I, what is the voltage drop across this mercury? Let us say this is mercury, resistor is mercury, VR. So, what is VR beta? So, VR equal to I into R. I is beta this. So, I is V RMS upon root over R square plus omega L whole square into R. So, you can say this much is voltage drop across this resistor. Resistor is our mercury tube, okay. Now, if it was simply directly connected, suppose this resistor was directly connected to this, then what would have happened? Tell me. Then across this voltage drop will be directly this VRMS. This will be equal to voltage drop. 100% this quantity is less. See, this quantity, this fraction is less than 1. This fraction is less than 1. So, I can say here when choke coil is used, VR is less than without choke coil. In this VR will be directly equal to applied voltage. So, here there will be almost less possibility of damage. So, first line is correct line, okay. Let us come to second line. By using choke coil, the voltage across the tube is reduced by a factor. Right now only we explained R by root over R square plus omega L square, that is what they have written, okay. So, you can say, and if choke coil were not used, you can say both I have explained already. It means second line is also correct, and reason is the correct explanation, because of this reason only we explained our first line. So, correct answer should be assertion is correct, reason is correct, and reason is a correct explanation. So, which option is there? So, you can see which option is there beta. I think option number 4, assertion is correct, reason is correct, and reason is a correct explanation, okay, fine. Moving to next one, okay. Next one is again a very simple question. What they are saying? Match the column. This is match the column. Let us come to this. First, electric field inside distance r greater than 0 from the center of uniformly charged spherical shell they are asking, shell, we should highlight shell, with surface charge density sigma. So, let us say this is cell and here you have charge q, and surface charge density sigma, its radius is something capital R, okay. Now, electric field inside, you know, at any inside point electric field is 0 for shell. So, I can say option A should have electric field 0. Which option? Option number 3. Now, electric field at a distance r greater than 0 from uniformly charged infinite plane sheet. So, you know, from infinitely charged plane sheet, what is electric field? At any distance it is sigma by 2 epsilon naught. So, which option is correct? Sigma by 2 epsilon naught, option second. Okay, coming to C. See what they are asking? Electric field outside distance r greater than 0 from the center of uniformly charged spherical shell. So, same thing, but this time outside. So, outside field we know it is 1 by 4 pi epsilon naught q upon r square. This is the basic idea, where q we will write how much, this charge q is beta sigma into 4 pi r square. So, sigma into 4 pi r square upon 4 pi epsilon naught r square. The 4 pi gets cancelled and this is sigma r square upon epsilon naught r square. So, this is, I think there is no such option out of these 4, there is no, even this is wrong. So, there is no such option. So, for C we are not getting any option, for C we are not getting any option. Okay? So, C we are not getting option. Let us come to D. So, what is D? Electric field between two oppositely charged infinite plane parallel sheets with uniform surface charge. So, it is simple basic capacitor. So, you can say one has plus sigma, one has minus sigma, you know, because of this also sigma by 2 epsilon naught, because of this also sigma by 2 epsilon naught. So, total field is how much? Sigma by epsilon naught. Is there any such option? Yes, option first. So, for this option first. So, A 3, B second, D first and C there is no such option. So, again this question goes to bonus, means examiner asked good question, but typographical error is here. 4 would have been a correct answer as per right now if this C option is changed, because C has mistake, because this fourth option typographical error is there. So, this question goes to bonus. Okay. Let us come to next one. Okay. Next question is, a body of mass m connected to a massless and unstretchable string goes in a vertical circle of radius r. Okay. So, this question is of vertical circle under gravity g. The other end of the string is fixed at the center of the circle. If velocity at the top of the circular path is n root gr, okay fine, where n greater than 1, then the ratio of kinetic energy of the body at the bottom to the top, it is such a simple problem. So, very simple idea. So, beta this is telling, this is our bob. What they are saying? Velocity at the top, at the top velocity is known, how much? N root gr, this is velocity at the top, V top, and he is telling n greater than 1. Why he is telling n greater than 1? Because otherwise tension will become 0 somewhere. So, he is telling, because here when velocity was exactly root gr, when n equal to 1, then here tension is just 0. So, he is telling that n greater than 1, so that tension is never 0 throughout the path and circular motion continues. Okay. Vertical circle is okay. Now, V bottom they are asking, it is a simple question of work energy theorem you can apply. Okay. So, from here to here you can apply work energy theorem or conservation of energy, whatever, both are fine. So, here to here you can say kinetic energy plus potential, let us apply conservation of mechanical energy. So, initially half m Vt square, Vt square is how much beta? N square gr plus potential, if I take this as my reference, so here potential energy is how much beta? Mg into 2r, correct, and this must be equal to final half m V bottom square and plus potential energy is 0. Okay, fine, very simple. This Vb they are asking, m anyway gets cancelled out. Okay, I said okay, very simple. So, what we will get here? I think gr is common, n square, and this 2 will go here, n square plus 4, okay, n square plus 4, correct, any doubt, and this is equal to Vb square. What they are asking? I think they are asking directly kinetic energy only. I calculated velocity, but okay, they are asking kinetic energy, means what they are asking? They are asking kinetic energy at the bottom, upon kinetic energy at the top. So, what is kinetic energy bottom? At a half m Vb square upon half m Vt square at top, this cancel. So, Vb square upon Vt square, Vb square is this value of gr n square plus 4 upon, what is Vt square? Vt already given, this is Vt. So, gr n square, such a simple problem, this gets cancelled. So, n square by 4 upon n square, which option is there? You can easily see which option is there. So option number 3. Option number 3 is correct answer. Okay, fine, great. Let's move to next question. Okay, next question is, if lambda and k are de Broglie wavelength and kinetic energy, okay, lambda is de Broglie wavelength and k is kinetic energy respectively of a particle with constant mass, okay, mass is constant, correct. Graphical representation of, so we know lambda equal to h by p, such a simple, h is Planck's constant and p momentum is root over 2 mk. They are saying that mass is constant, k is kinetic energy here. So, we have a graph of 1 by k versus lambda, okay, 1 by k versus lambda. So, let us square this beta. So, lambda square equal to h square upon 2 mk, okay. I said okay. So, 1 by k equal to 2 m by h square, okay, lambda square, okay. This is your y axis, this is some constant and this is something x axis. So, y equal to c x square, very simple thing. This is lambda is on x axis, you can see. So, y equal to c x square. How this graph is? This is parabola. This graph is definitely parabola and this graph will be like this. Here y is actually 1 by k and here beta x is what? Lambda. So, is there any such graph? Yes, graph number 2. 2 is correct graph. Fine, moving to next one. Next one, a pair of physical quantities not having same, again unit dimension, very simple problem. So, 2 questions are from unit dimension, 2 questions are from unit dimension, okay. So, not having same dimension they are saying, okay, not having same dimension. First one is pressure and Young's modulus, pressure P is force upon area, okay, fine. What is Young's modulus? What is beta Young's modulus? So, we know that stress equal to Young's modulus into strain. You can see it is dimensionless. So, dimensionally Young's modulus is also, it is dimensionless, length upon length. So, Young's modulus is dimensionally force upon, so pressure and Young's modulus both have same dimension. So, its dimension is same. Okay. Angular momentum and Planck's constant. Angular momentum is what? L equal to mvr, okay, mvr, that is what we can say, mvr perpendicular, correct. Right now here we are simply writing, anyway dimension is required, okay, fine. What is Planck's constant? So, E equal to h nu, a basic formula is there. So, E is energy, E is what? Energy. So, Planck's constant is energy upon nu. Nu is what? Nu is 1 by time period. So, 1 by time I can say, dimensionally time. So, it is energy into time, okay. Energy is m L2 t minus 2 and again one more t for this t. So, it is m L2 t minus 1. Now, let us come to this. What is angular momentum? M for velocity L t minus 1 and again here L. So, it is m L2 t minus 1, again same. So, second one has also same, but they are asking not same. Let us come to third one. Third one is torque. Torque is what? R cross F. Again beta, magnitude wise torque is F into R perpendicular. So, force and distance, force into distance. What is energy? So, energy is actually work, dimensionally energy is actually work, and work is again force into displacement into cos of theta. Cos of theta is dimensionless. So, this is only dimension. So, both have same dimension. So, torque and energy have same dimension, okay. So, definitely fourth is answer because all three we have checked. Let us check fourth one also. So, fourth one, surface tension. What is surface tension S beta? Force per unit length, force per unit length. And what is impulse beta? So, impulse is force into time dimensionally, because you know impulse is actually integral of f dt, change in momentum. So, again this is force into time, this is, so definitely surface tension and impulse, they do not have same, what we can say, dimension. No need to go for every time dimension, I did once, but for others directly by formulas we can check. So, definitely fourth is correct answer. Surface tension and impulse, they do not have same dimension, okay. Let us move to next one, question number 42, okay. What we have been asked? So, the fractional compression delta V by V of water at the depth of 2.5 kilometer below the sea level is, in percentage they are asking, fractional compression, okay, delta V by V, given that bulk modulus of water is this, density is given, acceleration due to gravity is also given. So, we know what is the formula for bulk modulus. Bulk modulus is minus V dP by dV. So, I think from here I can say dV by V, this is the fractional change, equal to minus dP by B. Minus sign is only telling that if you increase the pressure, volume will decrease. So, simply we are going to calculate magnitude. So, dP is what? If I am going 2.5 kilometer below, so obviously dP is the pressure difference. How much pressure will increase? So, rho GH. So, I can say rho GH, only magnitude I am writing, upon bulk modulus. This is delta V by V. They are asking percentage, so into 100, here also into 100 beta, and simply just putting the values. Rho is 10 raised to power 3, G is again 10, they have given, H is 2.5 kilometer, that is 10 raised to power 3, and again this is 100 upon how much? What they are saying? So, upon B, bulk modulus value is given, yes, it is given in SI unit, just check units. So, 2 into 10 raised to power 9, I think 3, 3 and 3. So, everything gets cancelled with 10 raised to power 9, 2.5 by 2, how much it is coming? It is coming 1.25%. So, here what should be filled? 1.25, yes, fourth is correct answer. Okay, let us move to next one. So, this is a logic gate problem. What they are saying, some gates they have made and they are asking that what is the equivalent gate. So, when you solve this, now it can be solved by Boolean algebra, but why we should go unnecessary with such a very simple method I will use. We will make truth table. So, let us say here A, let us say here B, and let us make output Y, simple, and we will check out of this. So, A is 0 and B is 0. First of all, you must understand this is a what? This is NAND gate, and this is what? NOR gate. Again this is NAND gate. NAND gate means what? AND gate plus NOT gate. Okay. So, 0 0, let us guess. So, A is 0, B is 0. So, 0 and 0 is going. So, 0 into 0 0, but because of NOT it will become 1. So, here it will become 1, first case. Here also 0 0, 0 plus 0 0, but because of NOT it will become 1. Now, 1 plus 1 and 1, here this is AND, 1 into 1 1, but because of this NOT gate it will become 0. Okay. Let us check. A is 1 and B is 0, check. So, A is 1 and B is 0. So, A is 1 and B is 0, just keep focus. So, 1 into 0 0, but because of NOT it will become 1. So, again this is 1, again this is 1. Now, here just check again, A is 1 and B is 0, 1 into 1 plus 0 OR gate, 1 plus 0 1, and because of this NOT it will become what? 0. 1 and 0, 1 into 0 0, but because of NOT it will become 1. I think next case exactly similar, you will get 1. Let us check last case. A is 1 and B is 1. So, A is 1 beta B is 1. So, 1 into 1 0, sorry, 1 into 1 1, 1 into 1 1, and this is NOT gate, so it will become 0. Here 1 and 1, 1 plus 1 1, but because of NOT gate it will become 0. Now, 0 and 0, 0 into 0 0, but because of NOT gate you will get 1. So, now see, we are ready with our truth table. A 0 0 0, 1 0 1, 0 1 1 and 1 1 1. This is truth table of which gate? OR gate. This is truth table of which gate? OR gate. So, definitely fourth is correct answer. Let us move to next one. Okay. Next question is, I think, again looking from mechanics. Let us read this, we will understand what they are saying. As shown below, bob A of pendulum having massless string of length r is released from 60 degree to the vertical. Okay. It hits another bob B of half the mass, okay, that is at rest on a frictionless table, okay, in the center. Okay, fine. So, this is coming and it is hitting here. Okay. Assuming elastic collision, the magnitude of velocity of bob A after the collision will be, okay. So, when it is coming after that collision is what? Elastic. So, let us come. When this will strike here, first of all it is coming. So, A, before striking, A will have some velocity V naught, this is A. How much velocity it will have? B is here, its mass is m I think, and its mass is m by 2. Okay. So, V naught will be how much? Tell me how much height? This is your height h. Can you tell me this height? This they have given r. So, this is r cos 60 degree. This much how much? R cos 60 degree means r by 2. So, h is also how much? R by 2. So, its velocity is root over 2 g h, which is root over 2 g r by 2, which is very simple, root g r. How much velocity? V naught is root g r. Okay. It will collide with B. After collision, let us say A will have velocity V A after collision, and beta B will have velocity V B. Okay. So, can I apply momentum conservation? This is your initial and this is your final. So, just apply momentum conservation. P initial is m into V naught, where V naught value is root g r, we will put this, and finally it is m V A plus m by 2 V B. Okay, m gets cancelled. So, we get V naught equal to V A plus V B by 2, very simple, first equation. Okay, collision is elastic, so I can say coefficient of restitution 1 equal to velocity of separation. Separation is what? V B minus V A, and velocity of approach. Approach, it was coming with V naught, second was at rest before collision V naught. This is second equation. We can easily solve this. For example, this equation will give you V B minus V A equal to V naught. Let us put this as second, not this one. Okay, first and second you have to solve. Simple, very simple, you will solve. You can solve these two equations. What they are asking, V A or V B? Just check. I think they are asking V A. Later they are asking V A. So, just solve this. For example, if you add these two equations, so V A gets cancelled out, and you will get first plus second if you add. So, you will get what you will get from here? V A gets cancelled out. Okay. This is this side. So, V A gets, and you will get 3 V B by 2, 3 V B by 2 equal to 2 V naught. So, V B equal to how much? 4 V naught by 3. Therefore, what is V A beta? V A from equation, let us say second equation, from second equation V A equal to V B minus V naught, that is 1 by 3 V naught, that is 1 by 3 V naught is how much? Root G R. Such a simple problem. Which option? Option number 2. Option number 2 is correct answer. Very simple thing, very simple thing. Okay. Let us move to next one. Okay. Again it is an assertion region. Okay. What they are saying? Assertion. Time period of a simple pendulum is longest at the top of the mountain than that at the base of the mountain. So, what is the formula for time period? It is 2 pi root over L by G. 2 pi root over L by G. This is basic formula. Now, what is G formula? G m upon r plus h whole square at some particular height. So, you can see as h increases, G decreases. As h increases, G decreases. So, definitely when G will decrease, time period will be more. So, I can say at peak of the mountain, height will be more. So, G will be less and time period will be more. So, I think statement first is correct statement. This is correct statement. What is second statement? Time period of simple pendulum decreases with increasing value of acceleration due to gravity and vice versa. I think same thing. Time period of simple decreases with increase. So, if G value increases, then time period will decrease and vice versa. So, definitely this is also correct statement, and I think this is the only explanation. Because of this only we explained this. So, I think both statements are correct and correct explanation is also there. So, which statement? I think option number 3 is correct answer. Okay, fine. Moving to next one. Okay, I think now we are in teaser questions. Okay, first question. A container of fixed volume contain a gas at 27 degree centigrade. To double the pressure of the gas, temperature of the gas should be raised to in degree centigrade they are asking. So, first of all, fixed volume. Fixed volume is what? Volume is constant. Volume is constant means what we can apply? We can apply very basic. Volume is constant. So, we can apply pressure is directly proportional to temperature. Correct or not? Volume is constant. So, pressure is directly proportional to temperature. So, from here I can say T2 by T1 equal to P2 by P1. Temperature must be put in Kelvin for solving. Now T2 I do not know, T1 is 27 degree, that is 300 Kelvin, 300. P2 by P1, what they are saying, P2 by P1 equal to 2. So from here T2 is 600 Kelvin, 600 Kelvin. But answer how much? Answer is in degree centigrade. So this is how much? 600 minus 273, that is 327 degree centigrade. So correct answer should be 327. What should be the answer here? 327. This is correct answer. Okay, fine. Moving to next one. Next question. Okay, I think again this question is from geometrical optics. What they are saying, two light beam fall on a transparent material block at points 1 and 2. Okay, 1 and 2 you can see in the diagram with angle theta 1 and theta 2 respectively as shown in the figure. After refraction the beam intersect at point 3. So 3 is here, you can see, which is exactly on the interface at the other end of the block. Okay, at the other end of the block, given distance 1 and 2. So 1 and 2, this d they have given how much? 4 root 3. Theta 1 theta 2 is something cos inverse n2 upon 2 n1. Okay, so above n1, below n2 medium is there. Okay, refractive index of the block n2 is greater than that of outside medium n1, then the thickness of the block. So they are asking this thickness, this distance, let us say this is h. So I think this h they are asking, very simple. Okay, let us make this diagram little bit zoomed diagram just for understanding. So that this way one ray is coming and this way one ray is coming, and they are saying that after that it bends like this, and after that it also bends like this, and exactly they are meeting here. Fine. Now they are saying that this angle is theta 1. First of all, this will be angle of incidence I, this will be angle of refraction r, okay, and theta 2 is also theta 1. So no need to worry, only one side calculation is enough. So this is r. Now if I draw here like this, you can easily understand this length is h and this is your angle r. Am I correct? Am I correct? This is beta n2 and this is n1. You can apply Snell's law. What you can say? n1 sin I equal to n2 sin r, n2 sin r. n1 sin I is 90 minus theta 1, theta 1 equal to n2 sin r. And now you can see n1 by n2 into sin 90 is cos theta 1. Cos theta 1 value is given. What is given cos theta 1 value? n2 upon 2 n1. Directly I am putting equal to sin r. You can say, so r is 30 degree, r is 30 degree coming, because n2 n1 all these gets cancelled, 1 by 2 is left. So this angle is 30, so this angle is also 30. So now they are asking this h. First of all they have given this distance d. This is whole is how much? 4 root 3. It means beta this distance is how much? 2 root 3. This distance is 2 root 3. Okay. Now tan r equal to, you can see 2 root 3 upon h. R is 30 degree. So tan r is 1 by root 3. 1 by root 3 equal to 2 root 3 upon h. So from here h is 6. H is how much? 6. Okay. I think in the question they have given units here. D is 6 root 3. I think in the answer they are asking in centimeter. We should be always careful in units what they are asking. In the question where they have given or not given, I think they have not given d equal to 4 root 3. If centimeter is given, okay fine, otherwise also we will mark what? 6. So 6 is correct answer. We will go with 6. 6 is correct answer. Okay, fine. Let us move to next one. Okay. Next question is, in a hydraulic lift, the surface area of input piston is 6 centimeter square, fine, and that of output piston is 1500 centimeter square. If 100 Newton force is applied to the input piston to raise the output piston by 20 centimeter, then work done is, okay, you know that energy is conserved in this. This is a simple Pascal law application, and what it says F1 by A1 is equal to F2 by A2. Pressure gets transferred from one point to another point without any change. Okay. So from here I can calculate F2. So F2 equal to F1 upon A1 A2. Now they have given output force we know, and output distance they have given. So work Work is F2 into whatever displacement, let us say S2. So, F2 is how much, Babu? F1 is how much? F1 is 100. So, F1 is 100 upon A1 is how much? A1 is 6 and A2 is how much? A2 is 1500. Both are in same units, so there is no need to change anything, and S2 is 20 centimeter, again definitely we have to change this, minus 2. Okay. Now, here I think 10 raised to power minus 2, this 2 will get cancelled, here 3 2 ja 6, 3 5 ja, this gets cancelled and this gets cancelled with 10. So, how much it is coming? This is coming 5 into 10 raised to power 3 joule, correct? Means how much? Answer is in kilojoule. So, it will be simply 5 kilojoule. So, correct answer is 5. Correct answer is how much? 5. Obviously, integer is there. So, correct answer is 5. Okay. Let us see question number 49. So, what we have here? The coordinates of particle with respect to origin in a given reference frame is 1, 1, 1. So, this is coordinate given. If a force of F equal to I cap minus j cap plus k cap acts on the particle, then the magnitude of torque with respect to origin in z direction. Okay, so torque they are asking, but only they are asking in which direction? Z direction, fine. So, let us calculate, let us see here R vector. So, R vector is simply I cap plus j cap plus k cap with respect to origin, and what is force vector is beta? I cap minus j cap plus k cap. Therefore, torque is R cross F, very simple. So, means I have to do I, j, k, 1, 1, 1, 1 minus 1, 1, correct? Solve this. So, I cap, here what I will get? 1 into 1, okay, 1 into 1. So, this will be how much? 2 minus j cap, 1 into 1, this will be 0 plus k cap, how much I will get? K cap 1 into minus 1, so minus 1, 2. So, it is actually with a 2 I cap minus 2 k cap, but they are asking only along z. So, torque z component is how much? Minus 2. Magnitude is torque z, magnitude is only 2. So, what I can say answer? So, answer is 2. What is answer? Answer is 2. 2 is your answer. Okay. Last question. The maximum speed of boat in still water is 27 km per hour. Okay. Now, the boat is moving downstream in a river flowing at 9 km per hour. A man in the boat throws a ball vertically upwards with a speed of 10 meter per second. Okay. The range of the ball as observed by an observer at rest on the river bank. Again, a very simple basic river boat problem, very basic problem. What they are saying? They are saying velocity of boat in still water means VBW, and this value is how much? 27 km per hour. Now, but if you can see, later you have 10 meter per second. So, data is in kilometer per hour also and in meter per second also. So, we have to change. So, we will see. Moving downstream, velocity of water is how much? 9 km per hour. So, tell me velocity of boat in downstream will be VBW plus VW, very simple, which is 36 km per hour. Okay. In meter per second it is 36 into 5 by 18. How much it is? It is 10 meter per second, correct? Okay. So, this way boat is travelling with how much speed? 10 meter per second in ground frame, correct? Now, a boy releases a ball upward with how much speed? 10 meter per second with respect to boat, boy or man, whatever. Now, so ball will have actual velocity in this direction also 10 meter per second in ground frame, and boat velocity will be also coming to it. So, its path will be something like this. What they are asking? They are asking in this range. So, range is simply with a 2 ux uy upon g. Just you have to put the value, 2 times of ux is 10, uy is 10 upon g is 10, 10, 10 gets cancelled, this is 20. So, answer is how much? 20. Answer is 20. So, this way we completed, I think, all questions. Questions were easy. Whatever ambiguity was there, that also we discussed, or whatever some bonus questions were there, that also we discussed. Okay, fine, thank you.